Hey guys, welcome back to Cam Room 5. So, we were doing physical chemistry ke questions from the year May June 2024. Let's begin doing more. I'm not going to do the number of proton electron, matlab it's not O levels. Part B. State and explain the difference in the ionic radius of aluminium 3 plus and magnesium 2 plus. So, we need to understand ke why they are comparing these two. Acha ji. Aluminium with an atomic number of 13 and magnesium with 12. So दोनों का configuration is 1s2, 2s2, 2p6, 1s2, 2s2, 2p6. They both have the same number of electrons. That's why we're comparing. So both ions have same total electrons. अब but कहाँ पर आ रहा है? But aluminium 3 plus ion has 13 protons, but magnesium 2 plus has 12. So aluminium 3 plus ion is smaller. Now why is smaller? More nuclear attraction with remaining electrons. Both ions have same number of shells and shielding. ठीक है जी, so that's it. Draw label diagram, structure and bonding in sodium. That's pretty O levels. मतलब I'm not doing it. O level types. I'm not doing it. Moving on. Figure 1.1 shows the variation in melting point of some period 3 elements in their standard states at room temperature and pressure. अच्छा जी, melting point दिखा दिया है. We know कि magnesium has higher and then aluminium has higher and then suddenly silicon has the highest because silicon का giant covalent structure होता है. So silicon is giant covalent. Now phosphorus is lesser than even sodium because वो non-metal है. So phosphorus is non-metal. Sulfur is non-metal, chlorine is non-metal, but what's the catch here? The catch is that phosphorus पे आके drop हुआ, sulfur पर आकर rise हुआ, chlorine पे वापस drop हो गया. Even phosphorus should be a little higher. Just so you guys should know, this is not the mark scheme, this is O level के questions. You will be like, oh, बेरोज mark scheme से पढ़ा रहा है. हाँ भाई, मुझे तो कुछ आता ही नहीं है. So drops here, then rises here, and then falls here again. That's my depression basically. We are so back. I'm so logged in. Explain why silicon has a high melting point. So silicon has giant covalent structure and then many strong covalent bonds between atoms, high heat needed to break them. We have done this sodium state of oxide at room temperature, so solid oxide, which is Na2O, approx pH of solution made when oxided. So you get sodium hydroxide, which has a pH of 13. Sulfur oxide is gas, which is SO2. When you dissolve it in water, you get a pH 2 because you get sulfur dioxide becoming H2SO3, which is a pH of 3 or 2. The solutions made in column 3 of table 1.2 are mixed together. Name the type of reaction that occurs. So that's an acid-base reaction. Write an equation to describe the reaction between P4O10 and N excess of water. So P4O10 goes with water, produces H3PO4. Why am I so sure? Because oxidation state of phosphorus is +5 and it remains +5. We just have to balance this also. So 4 phosphoric acid ban jayenge like this, and 4 3s are 12, so you get 6 waters, and then rest of this is already balanced. Moving on, what is meant by amphoteric? We know this already. Reacts with acid and base both. Why did I write aid? Kind of problematic, or is it? ठीक है जी. Write an equation to describe the reaction that occurs when aluminium hydroxide reacts with sodium hydroxide. अच्छा जी. So aluminium hydroxide reacts with sodium hydroxide. So obviously aluminium का property है कि aluminium oxide is kind of amphoteric. So you get NaAlO2, and then you can balance the rest of it. You will get water molecules, and then you'll balance it. You'll have to balance it. So I'm just looking at it. Okay, there's 3 plus 1. So there's double water over here. 2 oxygens on the right side. 2 oxygens here. So that's 4 oxygens. Oxygens are also balanced apparently. By the way, just telling you, the name is sodium aluminate. Separate samples of sodium carbonate, sodium bicarbonate react with HCl to produce the same product. That's a catch. Same product बन रहा है, ठीक है? Complete the reaction pathway diagram. तो वो तुम कर लेंगे. O level वाला question है, ठीक है? O level वाला types, because sodium hydrogen carbonate के साथ endothermic reaction है. Moving on. The value for enthalpy 1 is determined by the experiment using the following method. 50 cm cube of 2 mole per dm cube HCl, and initial temperature Ti दे दिया है. 0.0400 mole sodium carbonate is added. Okay. All the solid sodium carbonate disappears, which means sodium carbonate limiting reactant. The maximum temperature is T max दे दिया, which is 26.2. Describe one other observation that shows the sodium carbonate effervescence होगा. We know this because carbon dioxide gas is coming out. Whenever a carbonate is there and whenever hydrogen ions go in, they make carbon dioxide plus water. Calculate the value of delta H1. So I want you to understand that in delta H1, you have these two things reacting, right? Let me copy this equation on the next page so you know what's happening. I'll copy this here. Now, 1 mole reacts with 2 mole, right? But the problem is that you had added 0.0400 mole. 0.0400 mole of this. So you will need 0.0800 mole of this based on ratio. How much water was there? Like water was 50 cm cube because this is the amount of the liquid. So Q is equals to MC delta T. The mass of water was 50. Specific heat capacity was 4.18. The temperature change, how much temperature change happened? 19.6 and 26.2. So 26.2 minus 19.6, and then you divide the whole thing by 1000, so you get kJ. So heat is equals to, let's do it on calcu. What am I doing? 50 times 4.18 times 26.2 minus 19.6, 1.944 exponent 3, but divide by 1000, so 1.944 kJ. Now we find it out by 1.944 divided by moles, which is 0.0400. limiting reactant का mole रखेंगे, so divide by 0.0400. 4.859 exponent 4, pretty big value. 48.5 exponent 3. But I remember I did not remove the exponent now, so it's gonna be, what's the value again? 4.859 exponent. So it will be 48.59 exponent 3, and due to the conversion it becomes 48.59. Yeah, 48.6. And was it positive? No, temperature was increasing. Exothermic temperature increased. Thermal decomposition occurs when sodium bicarbonate is heated. ठीक है जी. Calculate the enthalpy change for reaction 3. ठीक है जी. Using the data in table 2.1, let's go back to table 2.1. This value is 48.6 with a negative sign. And the other value is given to us already. Now they want us to find out what? They want us to find out this change of decomposition. I want you to understand one thing. They were both giving the same products. This was giving 2 NaCl. This was also giving 2 NaCl. When HCl was added, right? Sodium bicarbonate gives you 2 NaCls. This equation is 1 times 27.2, but you are doing 2 moles now. So it will become 27.2 times double. 27.2 times double. And sodium carbonate gives you this value 48.6 for a single mole. So that is minus 48.6 for a single mole. This value is missing. Notice that this is an indirect method and this is your direct method. So x plus minus 48.6 is equals to 2 times 27.2. So you can find the value of x using the further mathematical calculation. X is equals to 2 times 27.2 minus 48.6, and you get the answer. Z is a salt that contains a period 4 element from group 2. When Z is heated, brown gas forms. So it's a salt, period 4, group 2. Period 4 group 2 is calcium. Brown gas is probably nitrogen dioxide gas. And when do you get nitrogen dioxide? You get it nitrates ke saath. So that has to be calcium nitrate. We have done this. Dynamic equilibrium is pretty O levels. We have done this exact question last time, so I'm not doing it. Values are a little different, but the question is very similar. For the sake of practice, we can do this. We can try that out. Why not? Why not? Let's do it now. Describe what is meant by dynamic equilibrium. An equilibrium made by reversible reaction with rate of forward and reverse reaction being equal and constant, I use square brackets, and concentration of reactants and products do not change. We have done this question, so I'm not doing it again. Okay, so this question says the expression for the equilibrium constant Kc for reaction 4 is shown. 5x.5 mole of iron 3 plus, so this is the mole of iron 3 plus, and 5x minus 5 mole of SCN, so I have the mole of SCN also, are added together and allowed to reach equilibrium. The total volume is going to be 25, so this is the total volume. At equilibrium, the concentration of FeSCN is given. Calculate the equilibrium constant. So we need to understand this fact. In the beginning, Fe3 plus was there, SCN was there, and FeSCN was not there. Initially 5x minus 5 This is also 5 square minus 5, and this is 0.00. At equilibrium, this is 5 exponent minus 5 negative something, I don't know what. This is also 5 exponent minus 5 minus something because some of it has been used, and this is x. Now, how much of it has been made? You know how much of it has been made because you can find out literally the moles of FeSCN by doing the concentration times volume. So the concentration is 4.23 exponent minus 4. The volume is 25 exponent minus 3, and this gives you the moles. So I'll just do the split screen. Calcu 4.23 exponent minus 4 times 25 exponent minus 3 because conversion bhi karna hai. 1.058 exponent minus 5. So 1.058 exponent minus 5. This has been made. Now if this has been made, iska matlab hai कि this is what you used. So the amount, the moles of iron in SCN can be calculated. Moles of iron at equilibrium is equals to originally, which was 5 exponent minus 5, minus the amount you used up, which was 1.058 exponent minus 5. Let's do it. How much moles of it are we left with? 5 exponent minus 5, negative answer. So 3.942 exponent minus 5. 3.942 exponent minus 5, and the concentration of Fe3 plus is equals to 3.942 exponent minus 5 divided by 25 exponent minus 5 because that's the negative 3, that's the concentration. So this answer divided by 25 exponent minus 3, 1.577 exponent minus 3. So 1.577 exponent minus 3, this is the concentration of iron 3 plus at equilibrium, and this is also the concentration of SCN minus at equilibrium, and iska to already given it, so we can just find Kc. Kc is going to be product, which is 4.23 exponent minus 4 divided by 1.577 exponent minus 3, but with a square because you have two of them. वो दोनों reactant same है ना, so you'll just do it and you put your answer. So units कैसे निकालेंगे? Units are going to be mole per dm cube divided by mole per dm cube का square. That's Kc units. So that becomes mole per dm cube. So dm becomes 3 and this mole becomes minus 1 because that was in denominator. Now ऊपर जाके it becomes reversed. Determine the full electronic configuration. Iron is 26, so 1s2, 2s2, 2p6, 3s2, 3p6, and then 3 electrons are subtracted, so it's 23 electrons. So 3d3. Dot and cross diagrams you guys can do better than me, but still I'm doing. Carbon is making triple bond with nitrogen, so 1, 2, 3 like this, and then it makes one bond with sulfur, and then carbon ka shell is complete, but sulfur, this is lone pair from sulfur, this is one electron, and this is the electron that it gains. Sulfur is the one which gains electron. So just showing you, this is the electron gained, and that's why it's a minus charge over here. This is an Organica question. I'm not doing it. I can jump on the next part and see if there's more questions, so we can do this. I'm back on physical chemistry. Organic we'll do separately. Explain the lack of reactivity of nitrogen gas. So first point is nitrogen to nitrogen triple bond has high bond energy, and second is nitrogen is non-polar molecule. So when you are a non-polar molecule, it is difficult or less readily attacked by nucleophiles or electrophiles. Neither electrophiles are attacking it, like trying to get electrons, nor nucleophiles are. Covalent bonds, acha. This we can do total number of bonds in N2. So sigma bonds, if I draw this, it looks like this. So there's one sigma bond, two pi bonds. How the orbitals overlap, so that's a linear overlap for sigma bond, and that's a lateral overlap for pi bond. A sample of aluminium reacts with excess of chlorine. State the oxidation number of aluminium in the product. So aluminium is always +3, not new for us. State what determines the maximum oxidation number. Maximum oxidation number is always positive, by the way. You can never have a negative max oxidation number. So what decides how much electrons you lose, how many electrons you lose? So based on number of electrons in outermost shell, the max electrons that an atom can lose. Give a state of aluminium and phosphorus. So aluminium oxide is solid. This is also solid, by the way. Write an equation for the reaction of each oxide with an excess of NaOH. So this is M for ferric, na? We have done this recently. So NaAlO2 बनाएगा and water बनाएगा. You'll make 3 oxygens and 4, so you'll make 1, 2, 3, 4, yeah. I'm just looking into it. Sorry, it was double over here. Yeah, now it's balanced. You have 1, 2, 3, 4, 5 oxygens, 1, 2, 3, 4 over here. सही है, ठीक है. 2 hydrogens and that balances it. Sorry. Then what else do we have? P4O10. So P4O10 is basically very similar to H3PO4, because as soon as it goes into water, you need to understand कि ये aqueous है ना, so it will make H3PO4. H3PO4 के अंदर you have 3 hydrogen ions and of PO4 3 minus ion. So Na will go with the PO4 ion, so you will get Na 3 times PO4 ion, and you will get all the water, so you will get water. You need to understand this thing, you need 3 of them, 3 sodium, so 3 of them, and the rest of it is perhaps already balanced. You can see 10 oxygen atoms here and then 3 here, so that's 13. Achha, by the way, also sorry, one more thing, 4 phosphoruses. You have 4 phosphoruses, so you get 4 of them, then 4 3s are 12, so 12 NaOH, and now it balances 6 H2O. What else do we have here in this? The oxide of silicon reacts with calcium oxide in an addition reaction to produce calcium silicate. The oxidation number of calcium in calcium silicate is +2. Reduce the oxidation number of silicon. So अगर calcium silicate है, calcium is +2, oxygen is -6. So that makes it -6 + 2, -4. So silicon has to be +4. Calcium oxide can be made from calcium carbonate. So that is obviously thermal decomposition reaction. Thermal decomp. This looks like a good equilibrium question. Let's do it. Nitrogen reacts with hydrogen in the Haber process as shown. You can see the forward is exo, the reverse must have been endo. Describe and explain the change, if any, to the percentage yield of ammonia produced in B compared to A. So in B you have iron catalyst. Catalyst is present only, so there should be no change. No change, as catalyst only speeds up the reaction. compared to C compared to A. So in C, you both have no catalyst, so that's okay. But your temperature is higher, so higher temperature. Higher temperature favors endothermic reaction. Which one is endo? Reverse is endo. So percentage yield of ammonia decreases. Higher temperature favors reverse endothermic reaction. Equilibrium shifts to left. Describe and explain the change to the rate of the forward reaction that occurs to establish the equilibrium in C compared to A. You do not need to refer to the Boltzmann distribution. So what we'll mention is just the fact you have a higher temperature. So higher temperature provides more kinetic energy, more speed of particles, more collisions per unit time. They don't want me to talk about the Boltzmann curve, इसीलिए मैं इस direction में नहीं जा रहा हूँ, about talking about how many particles have the energy. Write an expression for the equilibrium constant Kp for reaction 1. So reaction 1 दिया हुआ है ammonia का production, right? So partial pressure of ammonia with a square divided by partial pressure of hydrogen times partial pressure of nitrogen. Hydrogen पे cube आ जाएगा. Sorry, like the cube should be on the P. The units are going to be Pascal square divided by Pascal cube divided times Pascal. So इसने इनको cancel किया, it becomes Pascal over Pascal times Pascal. That is, apologies, ऊपर से तो cancel हो गया ना पूरा. So it's going to be Pascal -2. Equilibrium mixture D is made when 1 mole of nitro and 3 mole of hydro are added to a sealed container at 75 degree 1000 atmosphere and left to reach equilibrium. The mixture contains 1.16 mole of ammonia. Calculate the mole fraction. अच्छा जी. Nitro, hydro, ammonia. Initial at equilibrium. At initial 1 mole and 3 mole and 0.0 mole. At equilibrium you have 1.16 mole ammonia. तो 1.0 में से कुछ यूज़ अप हुआ होगा और इसका 3 मोल में से कुछ यूज़ अप हुआ होगा. You need to understand the mole ratio of nitro is 1, hydro is 3, ammonia is 2. Let's go back and let's ask ourselves, if we consider ammonia and we consider nitro, so the ratio is 2:1. 1 nitro makes double ammonia. ठीक है जी. 1.6 ammonia is made by how much nitro? Okay ji. So obviously if 1 nitro is enough to make ammonia, so 1.6 would be made by half. That is basically like cross multiplication. I'm not going into the details. So how much nitro will be used up? Amount of nitro used up is equals to 1.16 divided by 2. So I'll need my calcu. मतलब इस point पर my mental math like literally betrays me. So 1.16 divided by 2. 5.8 x minus 1, so 0.58. So nitro used up is 0.58. Leftover is gonna be 1.0 minus 0.58. So 1 minus answer, that is 0.42. 0.42 nitrogen is left over. Let's talk about hydro. The ratio between hydro and ammonia is 3:2. 1.16 ammonia is made by how much hydro? Let's just cross multiply. So amount of hydro used up is equals to 1.16 times 3 divided by 2. Let's do the calcu. 1.16 times 3 divided by 2. 1.74. 1.74 mole hydro is used up. So 3 minus 1.74. How much is left over? So 3 minus answer 1.26. 1.26 is left over, and how much ammonia was there? 1.16. Mole fraction of ammonia is mole of ammonia, which is 1.16, divided by total mole. So 0.42 plus 1.26 plus 1.16. These all will be added and अमोनिया का मोल टॉप पे. जस्ट रिवाइजिंग, आपने एक इनिशियल बनाया, आपने इक्विलिब्रियम बनाया, आपने रियलाइज़ किया कि इक्विलिब्रियम पे सम नाइट्रो इज़ यूज्ड अप, सम हाइड्रो इज़ यूज्ड अप, एंड देन फिर आपने लेफ्ट ओवर लिखा. योर इक्विलिब्रियम रिलाइज ऑन लेफ्ट ओवर मोल्स. The mole fraction of nitro is 0.625 in a new equilibrium. Calculate the partial pressure of nitro when the total pressure is 1000. So that's not that difficult. Partial pressure of nitro is equals to mole fraction, which is 0.625 times actual pressure 1000 atmosphere. So that is 625 atmosphere. When oxides of nitrogen escape into the atmosphere, they may be involved in formation of acid rain from sulfur dioxide, formation of photochemical smoke. Identify the role of NO and NO2 in the formation of H2SO4 from SO2 in the atmosphere. Use relevant equations. So what happens is that SO2 actually reacts with NO2 to make SO3 and nitrogen monoxide gas. NO later oxidizes itself and regenerates the NO2. So NO2 acts as a catalyst. SO3 is made, and now what does SO3 do? SO3 reacts with water to form sulfuric acid. The water comes from the moisture in the atmosphere. Now obviously I wrote it in a very jaldi wala tariqa, but you can obviously have your own method, and and you can write it like in a more justified manner, okay, how things are working in this scenario. Let me put it on charge. I'll have to put it over here. Outline how NO and NO2 may contribute to the formation of photochemical smoke. So just mention unburned hydrocarbons react with NO and NO2 to make peroxyacetyl nitrates, also known as PANs. That's it. PAN बोलने का एक नंबर होगा and unburnt hydrocarbon का दूसरा मार्क होगा. Write an equation to show the reaction for the standard enthalpy formation of H2O. Huh? What? Literally H2O. You need one gas, and you need half oxygen gas. This question is also very easy. I don't know why. I don't think we have to do this, to be honest. But chalo, I'll do it. You need double boron, so 2 boron solid. You need 2 ammonia, so N2 gas. You need 2 3s are 6, so 3 hydrogen gas. And you need 3 atoms of oxygen, so 3/2 oxygen atoms. You can either make this side or you can make that side. You can understand how making the reactant and then doing the reaction is a double step process, but making the product directly is a single step process. So formation of your reactant, which is B2O3, and formation of ammonia, obviously times 2, and then doing the reaction is basically equal to forming the Bn times 2 and forming your water times 3. So delta H for reaction 2 can be easily found out if formation of Bn कितना है -134 -134 times 2 formation of water कितना है formation of water is -286 times 3 इसको यहीं रहने दो and then bring these two on the other side, so that is subtraction में B2O3 -1264 and subtraction में ammonia which is -46 times 2. Do it and then you'll have your answer which you quote over here. Boron carbide is a hard crystalline solid that has a melting point greater than 2000. So giant covalent, 100 gram of pure boron carbide contains 78.26 gram boron. Calculate the empirical formula. Now 100 can be treated as a percentage. So amount of carbon is equals to 100 minus 78.26, which is going to be somewhere around like 21.73 something, I don't know. 100 minus 78.26, 21.74. See 21.74. So carbon and boron. Carbon is 21.74, boron is 78.26. Carbon should be divided by 12, boron should be divided by... What's the mass of boron? Boron has an atomic number of 5. Uska atomic mass शायद 11 है. Not sure, atomic mass over here. And then you take the ratio. I'm pretty sure it's a very simple question, so I'm not going into the details. We'll do this question and then we'll pause when the organic part begins. Draw a diagram to show the ionic, covalent and coordinate bonding present in a formula unit of ammonium fluoride. So ammonium fluoride is formed like this. Like this. This is whole thing called ammonium ion, and then you have the chloride ion. An exothermic reaction occurs when ammonium is added to OH minus. Identify the type of reaction. So ammonium is an acid because it has extra proton. OH accepts H plus, so it's a base. So it's an acid base reaction. Construct an ionic equation. So ammonium ion is a proton donor and OH ion is a proton acceptor. So proton accept करके वो water बन जाएगा और बेचारा अमोनिया गैस के तौर पे रिलीज हो जाएगा. Name the role of ammonia and OH in these reactions. अच्छा sorry, substitution reactions ammonia and OH. अच्छा यहाँ पर in organic they both have their lone pair, right? So they both are good nucleophiles because they have their lone pair which can be donated. Suggest which species is more reactive during these reactions. Explain your answer. Now, that's a good question. OH has two lone pairs on central atom, which is oxygen. That is oxygen. And also, it is negatively charged. So donating electron pair happens more readily. Ammonia has only one lone pair on central atom. So फिर जाहिर सी बात है which is less readily happening. Now we have organic chemistry coming in. वो तो हमने तीनों पेपर के साथ में करना है. Stay tuned guys for the next video. Bye.